Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, your course code ACH 503 and its title is Applied Organic Chemistry. I am your instructor Dr. Tehseen Gulzar. Now, coming towards your syllabus, what I have to cover under the topic of Applied Organic Chemistry, this is your syllabus. You have 4 credit hours for this course. 4 credit hours mean that if each and every credit hours is of 20 marks, it means this has 80 marks. 3 into 20, 60 marks are for theory and 20 marks are for practical. So you have two final term and mid term. Final term has 30 marks, whereas for your sessional 12 marks and for midterm 18 marks. 18 plus 12, 30 and 30 for final, 60 and 20 for your practical. Now, if we see the syllabus, you have three main or major topics which will be covered during this course. One is structure and reactivity. Second, stereochemistry. And then rearrangement, molecular rearrangement. In structure and reactivity, we have to cover the effect of structure, medium, and the steric effects on the strength of acids and bases and on acid-base equilibria. Then you will cover the very important topics as resonance, inductive effect, hybridization, and I am sure and it is that you are very much familiar with these concepts. Now, why acid and bases are important? Because the reactions of chemistry, they are better understood by these acid and bases. So some mathematical approaches are also or will be discussed during your structure and reactivity topic, like pKa, pH, linear free energy relationships, um, like the Bronsted catalysis laws, Hammett equation, Taft equation, and applications and limitations will also be discussed. And then in these, when we will study these factors of resonance, inductive, hybridization, hydrogen bonding, these are just few topics, but during study of these topics, resonance like delocalization, aromaticity will also be undertaken to clarify the concepts. Inductive effect, positive, minus, hyperconjugation, all these uh, factors will be discussed, and hybridization, no doubt that sp3, sp2 and sp, how they affect the acidity or basicity reaction in acid base reactions. Then the most important and which is considered to be very difficult during your studies for organic chemistry students, they think stereochemistry as a Hawa. They consider it as difficult because it is conceptual, and most of the students they are due to difficulty in understanding or concepts they face problems. So inshallah I will show you some videos. I will take some models to clarify those difficulties, and in future inshallah you will not feel uncomfortable while studying your stereochemistry. So before going to stereochemistry you should be well aware of isomerism. Isomerism is divided into two major categories. Number one is structural isomerism, or it is also well known constitutional isomerism, and another is stereochemistry. Because structural isomerism or constitutional isomerism, you can draw it on the whiteboard or on your copy or whiteboard, so it is difficult to understand there. But stereochemistry, as it is 3D version, so XYZ axis or in space, and many structures, you are not able to draw it on the paper easily. These should be drawn uh, as 3D versions. So that is why this is difficult for many. Those students who are intelligent or they have good vision, they can understand, but majority of the students like us, they are unable to understand it clearly until and unless they see models. They will be able to understand what is tetrahedral geometry, because trigonal, it is sp2 hybridized is planar, so it could be drawn on the paper or whiteboard. But sp3 or tetrahedral geometry and other geometries, it is difficult to draw on paper, but some artists or good students, they can draw. Okay, now in this stereochemistry, I will teach you not only geometric isomerism but also optical isomerism. Geometrical isomerism, cis, trans, Zeusagen and Tagagan, commonly known as ZE uh, conventions, syn, anti, erythros, threos, etc. Then how we will, what methods will be used to determine the configuration? One is conformation. Conformation means rotation. They are single bonded compounds, and configuration when they are double bonded, rigidity is present. If you move the bonds like gauche, anti-conformation on single bond, if they differ, if the structure is differing due to rotation on single bond, then conformation. And if they are isomers due to rigidity of double bond, then they have configuration. Now this type of geometric isomerism is present in both cyclic and acyclic compounds. And when you will study isomers, optical isomers, then you have to be careful about chirality. And sometimes this chirality is due to the whole system, and their symmetry is responsible for their chirality. Otherwise, chiral carbon is very simple to define. Any carbon which has four different groups on it, then this is chiral carbon. This will be chiral carbon. And then what are the elements or centers of chirality? What is prochiral and prochiral? Stereoisomeric. These are some compounds which are themselves not chiral, but they have tendency to form chiral compounds when they are attacked by incoming group. Like carbonyl compound, it is sp2 hybridized. This could not be, this is not chiral, but when any nucleophile attack the electrophilic center of carbonyl carbon, so that attacking nucleophile will generate new chiral center. This is chiral. After attack will be chiral. Carbon, otherwise when it is carbonyl carbon, this is not chiral but this is prochiral. It has tendency to make chiral center. Then we will study rectus and sinus uh, configuration. Then you will come to know what is racemic mixture, what is epimerization, what are epimers in sugars, in carbohydrates. Epimerization is very significant and important aspect of this isomerism. You will or you might have seen in second semester also. I taught you about how sugar chemistry you can make, you can draw the isomers of glucose. Carbon, there is a formula. If one stereo center, then two isomers are possible. If two, then there is a formula. You can, if four, then you can have how many isomers. I will tell you afterwards when we will go through this topic. Then Walden inversion. In because nucleophilic attack, you will study nucleophilic attack. It could be SN1, it could be SN2. Then when there is a racemic mixture, when two isomers or stereo isomers are mixed in equal quantities or in different quantities, then how will you separate them? How you will purify them? This is known as resolution. Then you will come up, towards another topic, asymmetric and stereoselective synthesis. Then third and the last topic is molecular rearrangements. You will be you will study types of rearrangements, their mechanisms, either nucleophilic, electrophilic, free radical reactions, and then migration of carbon or hydrogen to electron deficient as well as to electron rich center. Then important reactions with respect to aromatic rearrangements, these could be inter, that is between two molecules, and intramolecular, that is within the molecule. How migrations take place, how migrations take place from oxygen to carbon. Now for your uh, if we come towards practical, this is again you have to be careful about I will give you lectures, and I have already given you many lectures which are covering these given uh, topics, um, like branches of chemistry, what is localized, delocalized, what is hybridization, bond angles, bond lengths, and what are their shapes, and how dipole moment is important to understand electronegativity, uh, field effects, resonance, aromaticity, etc. All these notes are provided to you, and some theories about acid bases which were very which you were about those uh, theories of acid bases you are very much aware, but I have given you notes to revise those concepts properly. Then hydrogen bonding, solivation, spectator and ions. I have given you related to this some quiz as well, some assignments as well. So these factors are very important in understanding many of the reactions. We are generalizing acid bases to understand these reactions. So naming them is also important. IUPAC, the nomenclature of hydrocarbons, alkyl halides, alcohols, ethers, phenols, carbonyl compounds, amines, carboxylic acids, and their derivatives. Like carboxylic acids have esters and hydrides. Okay. Now I have briefed about uh, isomerism. That I will first I have to cover constitutional or structural isomerism, and then you will be able to differentiate between uh, stereochemistry and general uh, constitutional isomers, because nothing is absolute. You cannot understand things clear absolutely, but when you compare the things, your vision becomes uh, crystal clear. Like if I say elephant is big, but how big, you don't know. There are many things, there are many another things which are bigger than elephant, like rocks, like mountains, and so on. And if I say red, there are so many shades of red, light shades, tones, and dark. Blood red is very different color, but if you see rose, this is different red color. So there are many options or many varieties of red color, or any short or big things, large things. You measure, you make measurements in centimeters or meters or kilometers. So you compare the things. When you compare, things becomes easier. So when I will tell you about isomerism, constitutional and stereoisomers, it will be easier for you to understand. Then there are many ways to express those orientations in space. RS, um, and in geometric isomerism, Z, E, cis, trans, syn, anti, ethros, threos, etc. Now, uh, optical isomerism is very important. Mirror images are very important, and there I will tell you how to name those compounds, how to assign configuration, whether it is R or S, because there are many other configurations like small d, small l, capital D, capital L, uh, D glyceraldehyde capital is another way to express the stereochemistry, and small d and small l, this is another way to uh, dis- uh, to tell about stereochemistry of any chiral compound. So I will clear all these isomerism to you, inshallah. There we will discuss about elements of symmetry, centers. of symmetry, and how these elements and centers of symmetry produce chirality. Prochiral, I have discussed in previous slide that any compound which is itself not chiral, but when any compound it attacks that prochiral center, after attacking that carbon or that center becomes chiral. It has tendency to form chiral compound. Then you will not only observe, or there are many compounds in nature, like natural compounds, secondary metabolites, they are chiral, and not only one carbon is chiral or one center is chiral, there are a lot of other carbons which are chiral, like sugar, like glucose. There are more than two or three or four chiral centers in it. And as I told you, prochiral, there is a prochiral center in it that also becomes chiral when intra attack of one hydroxyl group attacks that prochiral aldehydic carbon, and that aldehydic, the prochiral carbon becomes new chiral center. So five chiral centers are present on just glucose, and it has a lot of other isomers. So many isomers are formed during this process, and this is well established in sugars. Okay, when we will study, it will be very easier for you. Then the last is, topic will be dealt under the heading of molecular rearrangements. You will come to know that how many types of rearrangements are occurring in nature, their mechanisms, whether they are nucleophilic or electrophilic or free radical rearrangements. Then in previously also I have told you about migrations, um, nitrogen and oxygen, carbon migration, hydrogen, and carbon migration to electron deficient is centers of carbon, nitrogen, and oxygen, and carbon migration to electron rich carbon. Then there are many other important rearrangements, like aromatic rearrangements, inter and intramolecular carbon migration from oxygen to carbon. Now there are a lot of books, very simple books. First of all, which I suggest is Solomon's, Volhard, Peter Sykes. I recommend, but it becomes difficult for some students. So Peter Sykes is also very good book. It is very short, and you can keep it in your purse pocket. It is so small book, easy to handle, portable. Other books are very, Solomon's is thick book, and Robert Casirio, because during college studies you can also use that reference book, Robert Casirio, uh, Peter Sykes Shom series. This was very important. Hard is very good book, simple, in simple words. And Solomon's, Jerry March is is very good reference book, but it becomes difficult for students to understand. So Clark, Morrison, and Boyd, very good book. And then there are many textbooks of Indian authors, Pakistani authors. You are using as well, and you can use. Bogle is very important book, and you are Stott Warren is very important. Now I want to tell about you practical. Three categories that for chirality, specific rotation or optical rotation, uh, you have to use polarimeter. So polarimeter will be used to know about or estimate the optical activity of any chiral compound. Then you have to identify organic compounds, identification of organic compounds. You will perform some dry and wet tests. Given compounds may be um, acetic acid, benzoic acid, glucose, oxalic acid, tartaric acid, citric acid, resorcinol, benzamide, thiourea, etc. Here you will perform some preliminary examination, then you will detect which element is present in it, then you will come further towards functional group detection, and at last derivative preparation to conclude categorically what the compound is. That on the basis of melting point, it is not easy or recommendable to identify any organic compound, because there are billion of compounds in the world uh, which have same melting point, and mostly they have same elements. Mostly they have same elements, same functional groups, but they differ. They could be confirmed after derivative preparation. Then you have some techniques to purify, isolate mixed compounds through fractional distillation, using rotary evaporator, or crystallization. Steam distillation is another way to purify any compound. So I have discussed here uh, some branches of chemistry. Uh, there is. I'm winding, and in next lecture I will discuss about this. It is just revision of your previous knowledge. You know very well, but to summarize the things, in next lecture I will start from this slide, that what chemistry is, and what is the significance of chemistry, what, because it is very vast, and we cannot study simply under the heading of organic chemistry. So uh, for the sake of simplicity, many branches, sub branches, classes, these are classified to understand easily that under the umbrella of this branch what we will cover. So it is better now that I hope, going through these five previous slides, you are now um, able to understand or able to follow that what course contents you have to follow, you what should you know. So thank you very much.